So here it is, dy dx equals, so you differentiate each term individually. So differentiating 3x, you get 3. Right, that was rule number 2. This one is rule number 1. Bring the power down in front. If there's a number already there, multiply it. So bring the power down in front. 2 by 4 is 8. So that's 8. And reduce the power by 1, which is 8 to the power, x to the power 1. Here, you bring the power down in front, so it's 3 times, and you multiply it by the third, because the third is already there. Okay? So that means dy dx is equal to 3 minus 8x. Now, 3 multiplied by a third is 1, girls. Do it on the calculator. 3 by a third is 1, so that's 1x squared, right, or just x squared. Is that okay? So that's number 21. Does anyone need me to do any of the other ones from homework? 16 to 25, was it I said? Yeah. Anyone? Okay, we're all good. So, right, okay. At the start of the week, I said I'm going to show you how, right, and I said by the end of the week I'll tell you why. So this is why, right? Okay. So we were doing, when we were doing a coordinate geometry of the line, we talked about the slope of the line. Remember, the slope of the line is how steep it is, right? So if you have a line A and a line B, A obviously has a bigger slope because it's a steeper line, okay? So when we were doing coordinate geometry of the line, we learned that if we had the line written as y equals mx plus c, as in y equals everything else, right? So y is on its own on the left hand side and everything else is over on the right hand side, we learned that the slope is the number in front of x. So the number in front of x is the slope, okay, when it's written like that. For example, y, the line, this is the line. How do you know it's a line? There's no x squared term, it's just x. So y equals 4x plus 3, right? How do you figure out what slope this has? Right, it's the number in front of x, so this has a slope of 4, right? Okay, this one is y equals minus 8x plus 1, right? And in the coordinate geometry of the line chapter, we would have learned that this, once it's written as y equals everything else, that the slope is a number in front of x, so this one has a slope of minus 8. Okay, so that's what we learned in coordinate geometry, right? Another way to find the slope, girls, is to find dy dx. So that just means if you're finding dy dx, you're actually finding the slope of the line. Okay, so that's what we're doing. That's the reason we're doing dy dx, is to find the slope of the line. So it's another way to find the slope of a line, or a curve, as time, I'll tell you that in a while. Okay, so another way to find the slope is to find dy dx. Okay, so instead of saying find the slope of a line, I said find dy dx. Okay, so they're the exact same thing. Okay, so if I just take the examples I have up here, so example 1, if I say y is equal to 4x plus 3, and I asked you to get dy dx, so dy dx, when you differentiate 4x plus 3, you just get the number in front of x, which is 4, right? Okay, and plus 3 is the, when you differentiate 3, you get 0. So your answer is 4. Okay, so this is the slope of the line. See, it's the same answer as I got up there. This is the slope of the line. So finding dy dx is another way of finding the slope of a line. Right, example 2, sorry. Can I take away the first part? Have we this down? If I do this, have I cut anyone off? Yeah. That's okay? Right, example 2. Yeah. Example 2. So if I just take the line I had above there, y equals minus 8x plus 1. If I find dy dx of this, so remember rule number 2, if If you differentiate an x term, you just get the number in front of it. And if you, rule number 3, if you differentiate a number on its own, you get 0. So dy dx here is minus 8. Again, this is the slope of the line. That's what I just said above. So the whole point is, right, okay, that if you're getting dy dx, so the reason we're doing it is we're getting the slope of the line. Okay, so at the start of the week I showed you how, now I'm telling you why. And the why is because you're getting the slope of the line. Okay? Okay, well what if the line, what if it's not a line? What if it's a curve? Right, okay? What if it's a curve, as in you did questions there with x squares in them and x cubes, that means they're curves. Okay, so what if it's a curve? How can you get the slope of a curve? Right, so I'm just going to take this curve here. Right, the slope of a curve is always changing. Like at this point, this is the slope, and at this point, this is the slope, and at this point, this is the slope. Okay, so the slope of a curve is always changing. It depends on what point you're at. Okay, so a curve doesn't have a set just a number slope. It's always changing. So here it might be 2, over here it might be 4, up here it might be 6, over here it might be minus 3, you don't know, right? Okay, so the slope of a curve is always changing, but we can still get the slope of the curve, girls, by getting dy dx, but we don't get an actual number, we get an expression for the slope of a curve. For example, so this is example 1 under slope of a curve. If we have a curve y equals x squared plus 3x minus 1. There's a curve, okay? It's a happy face, right, okay? Because it's got an x squared term, that means it's a smiley face curve, okay? So if I get dy dx, girls, right, okay? If I get dy dx, I get 2x plus 3. So instead of getting an exact number, I get an expression. So this can change as x's change, right? Okay, this is the slope of the curve. So it's just an equation to get the slope of a curve. So that's at every single point on the curve. So the curve is here. So the slope of this line is 2x plus 3. The slope of this line going across here is 2x plus 3. Right? Okay. What changes is the x term changes. Right? Okay. So if we find this at x equals 1, if we find this at x equals 1, remember last night we were learning how to do it at x equals 1. That just means everywhere you see an x, I put in a 1. So that would be 5. So if this was x equals 1, the slope of the line here would be 5, right? If I did it at x equals 2, that means the slope of the line at x equals 2 would be 7, okay? And if I did it at x equals 3, I get a different number, okay? So you can see the slope is always changing, right? But you just have a general expression to get the slope of that curve, okay? Does that make sense? Right, and I'll do example 2. So find the slope of the curve. Sorry, I forgot to tell you that these lines here, they're called tangents. Okay, so a tangent is a straight line that touches the curve at one point only. Okay, so we're not actually getting the slope of the curve, we're getting the slope of the tangent, which is the straight line that you draw at that point. Find the slope of the tangent x equals minus 1, right? Okay. Oh, to the curve, I never told you what the curve was. Y equals x cubed plus 3x squared minus 2x plus 4, right, at x equals minus 1. So all you have to do is get dy dx. So if they say find the slope of the tangent to the curve, you read that as find dy dx. So you just get dy dx, which is 3x squared, bring the power down in front, reduce the power by 1, right? Bring the power down in front, multiply by the 3 that's already there, reduce the power by 1. Here it's an x term, so it's just the number in front of x, and the 4 is just a 0, okay? And then we have to find that at x equals minus 1, so that means everywhere I see an x, put in a minus 1. So minus 1 to be squared plus 6 times minus 1 plus 2 into the calculator of that, and you'll get minus 7. So the slope of the tangent at that point is minus 7, right? So this would be a cubic, it would look like something like that, okay? And I'm basically looking for the slope of this line, okay? So something, if this is x equals minus 1, I'm looking for the slope of that line. Is that okay? Right, okay. I'm not giving you any homework because I'm going to see you all on Monday, and we'll get stuck into the work, okay? And I'll start with more examples of these. So when you've this written down, you can head off and have a nice weekend, and I shall see you all in person on Monday. Okay? Right, bye guys. Bye now.